ऐसा कीजिए, इसको इस साइड कर दीजिए या तो Are there any questions from the last class? Anything? I think, well, I will be, as I said, somebody had sent a mail to me for uploading of the video lectures. I will do that. I have to just get it set up because the format in which I'm getting, was unable to upload it on YouTube. I'll do it. But anyway, now at least after the tensor notation, if you read the textbook, I'm covering pretty much from the textbook. So therefore, and you can look at any edition, it doesn't matter, the text at least doesn't change. Mainly the problems change, but the text and the solved examples, all of them are the same. So if there is anything, any gaps to be filled, you can refer to the textbook. Somewhere I think in these days, there is a tendency not to read textbooks. Am I right? Am I wrong? Now, I think we should probably try to look at us, and that's why now I'm following the text rather than following multiple texts, so that you can easily get to the thing. Okay. So, last class I was talking of torsion, where we apply a twisting moment, a twisting torque on a circular shaft. Now, the reason why we are considering circular shafts is because in a circular shaft, the distortion is axisymmetric. So, therefore, the only component of shear which comes is tau. If this is z axis, then tau z theta and tau theta z. They are the only forces which come on a plane which is perpendicular to the axis of the torque. So that is why we are considering this case. The more complex cases we will not consider, and if the section is not circular or not axisymmetric, then we will get other components of torques also, because then circular sections will not stay circular, or any section will not stay planar. There will be out of plane deformation also. And here we developed, using our simple concepts, we developed this formula phi AB is equal to T times L by Jg. G, of course, is a property of the material, and T is the torque, L is the length of the shaft, and J was the polar moment of inertia. Integral R square dA. If you look at any section, you look at it, it is something like IZZ, because IZZ will be equal to integral of x square plus y square dA. So this J is also what you have seen in your course as IZZ, but without the mass, only the geometrical part. So density has been removed there. So that is what J is. And we showed for a circular shaft it was pi by 2 c to radius to the power 4. Okay. Now, I was talking of this case, and let's look at this case in a bit of detail. That there's a shaft which is bound to between two ends, two fixed ends, and a torque is applied somewhere, maybe not at the center, it could be off center also. So, this could be LA and this could be LB. Now, if the twist at this point, so let's call this center where the torque is being applied, let's call that point as C. Now, the twist on the left side, if we say this is equal to AC, and the twist on the right side is equal to BC, then when I say phi 1 plus phi 2, we have to be a bit careful in how we write it. One way of looking at it is, if I look at a point just to the left of C and just to the right of C, then, and if we cut a section to the left and to the right. So, first when we cut a section, if I draw a free body diagram of the left part, so I will have let us say the torque, because on the two ends you will have forces and torques. So, the torque on the left end, let us say, is TA. And if I draw a free body diagram of the right part, then I will get a torque TB. And because I am cutting at the right section, TC actually does not come into picture play at all. I am cutting a section, on the left side, because of the wall, of course there will be forces also, but they will not matter because, so what I am saying is the torque will be TA. And on the right side, the torque will be TB. And then what does equilibrium tell me? If I draw the equilibrium of the full rod now, what will I get? TA plus TB will be equal to T. Or I could have actually taken TA and TB, they are unknowns, I can take them in any sense and then I have to add them up. If I have taken a wrong sense, I will get a minus sign. But the way I have taken this, what I will get is TA plus TB, which are on this sense, plus TC or minus TC will be equal to 0. And TC is given to me. So now the full free body diagram. So let me just full FBD will be TA, TC and TB. So I will get here TA plus TB is equal to TC. Is that fine? So now TC is given to me, TA and TB I can't find from this equation. This is what Newton's law tell me. Okay. So these are the equilibrium equations. So this is a statically indeterminate problem. I can't solve this by equations of statical law. So then, if I look at this point C, which is just to the left of TC, and I look at this free body diagram of the left, then what can I get about phi at C? The angle by which, or this will translate. So phi at C will be equal to TL by JG, isn't it? We have already seen this. So if I look at the left side, what I will get here is phi at C, and I can maybe say it's C with respect to A. This will be equal to TA times LA by G times J. I am using G and J, I am not putting GA, JA. That would have been done had the two parts been different. Suppose if the geometry was different for the rod for the two halves, then I would have had to put GA, JA and so on. Those will leave for the exam. Okay. A rod with different type of this thing. Similarly, when I go to phi of C from the right side, what will I get? Phi at C will be C with respect to B will be TB LB upon GJ. And the point B, C, by continuity, has to be at the same location. So therefore, what I will get is TA LA upon GJ must be equal to TB LB upon GJ. So that gives me the second relation between TA and TB. And then I can solve. So this is how we'll do this. So on the right side when we do this, so from here I can write phi of C with respect to B. This will be equal to TB LB upon GJ, and then we will have, so TA and then we can solve this. Now, in the last class I had written phi 1 plus phi 2 is equal to 0. This was in the sense that I was continuing the same phi. But actually phi 2 is minus of TA LA upon GJ. So that's how these two can be reconciled. If you look at it, I'm twisting from the right side or from the left side. If I'm counting the same phi, then one of them is negative. And that's why this phi 1 plus phi 2 is equal to 0 is written in the text. But then I was thinking of how to explain it to you. And then what I realized was the best way of explanation is to say that the point C is at the same location because of the twist, and that one can explain using what I have written here. So if you use phi 1 plus phi 2 is equal to 0, then you have to use phi 2 is equal to minus TB LB upon GJ. And then you will get the same thing. And that is what the book uses. Okay? So this is the way we can solve statically indeterminate problems. That we apply the deformation compatibility. The compatibility of deformation here was that point C, it will twist it by the same amount with both these things. So that is what gives us the additional relation because of the property of the materials. If the bodies were purely rigid, we could not have solved the problem. We need these deflection relation and how stresses are related to strains to be able to solve the indeterminate problems. And what you will also realize is because when the problem becomes indeterminate, then an extra torque comes in, or there's an extra force which is there. And these forces can be quite high because the deformation compatibility causes, for a small deformation, you need a large force. So for it to be compatible, large forces are developed in the materials, or large torques are developed to be for them to be constrained. And that is what leads to failures, etc. And that's why failure then becomes important. And for failure, what do we count? We look at the stress, not the total force. And we look at the maximum stress. Okay? Now, let's start. So what I'm going to do is, has this lecture been uploaded? It has, but I will re-upload it. I will just, so that this part is also included. So I will upload it again. I'll delete that and upload this again. Okay. So now let's, so this was from yesterday. I wanted to take up another example for the let me try to draw the figure properly from the book so that so let's see if this picture is clear. Let me explain this. This is again problem from the book. So if the figure is not very clear, you can refer to the textbook. What we have are two rods. The rod CD, which is a circular rod, is fixed at the end D. So at the end D, it is fixed in the wall. At the end C, there is a gear which is mounted on CD. And the gear meshes with another gear at B. And the center of B, there is a rod which passes through a bearing. And a torque T0 is applied at end A. So this is how in fact power is transmitted from one shaft to the other. There is some sort of a contact, and through the contact, so now if one of the rod rotates, it will cause the other to rotate also. Do you see so just sort of try to absorb in the geometry first. End D is fixed and T0, a torque is applied. So if the rod will rotate, the free end is end A, where a torque is being applied. Okay. Now let's specify what is given in the problem. What is, well, the length CD is given as 900 millimeters and the length AB is 600 millimeters, and what else is given? The diameters, etc. must be given there. Let me just see. this radius, so radius of gear at C is equal to 60 millimeters, radius of gear at B is equal to 22 millimeters. And the diameter of the two rods, the first rod, the diameter is 25 millimeters, the diameter of the second rod is 19 millimeters. And then the material is given, these are made of aluminium, and so just put this here. Both rods of aluminium with G is equal to 77 GPa. And the maximum or allowable shearing stress is equal to 55 megapascal. That means if the stress in any of the rod exceeds 55 megapascal, the rod will fail or it will deform plastically. So, maximum shear stress it can take is 55 megapascal. So, now the question is, part A, largest T0 which can be applied at end A, and B, the angle through which end A rotates. So, let us read the question, let us try to understand what it is saying. थोड़ा सा नीचे कर देते हैं. So, now when T0 is applied, it will cause a shear stress in the rod AB because the gears are in contact. Torque will be transmitted on rod CD. Okay. And then because there is a torque transmitted on CD, there will be a shear stress in the part CD. So, we have to calculate both the shear stresses and see where it will fail first, and that will decide T0. Okay. So, now to solve this problem, what we will need to know is how much torque is transmitted on the other rod in terms of T0, and then relate that to the stress. And to find the deformation at which end A rotates, the deformation at D is 0, the angular twist, D is fixed. So, we will calculate the twist in C with respect to A. Okay. Now, then we will have to work out a relation how the twist in B is related to the twist in C, and we will do that. I will show you how to do that. I think some of you can already figure that out, that if C rotates with a particular angle, how much will B rotate? So, exactly. So, some of you, and then once we know this, then we will say, so we will get the twist in B. Then we will have to find the twist at A with respect to B because of this torque T0, and add that to whatever B has already twisted because of the left side, and that will give us the total twist. So, this is our sort of strategy to attack this problem. So, we need basically two things: how much torque is transmitted given there is a torque T0 on the rod AB. What is the torque which is transmitted to rod CD? Okay. And also, what are the relation between, if B rotates by an angle phi B, how much will A rotate at the same point? And then we have to use our relations. Okay? So let's start solving the problem. If I look at the gear at B, then on this gear, there will be some forces which are coming at B because of the rod. So now let's see what I have done. I draw the free body diagram of the gear. Then on the center, I will have two forces which are coming. Let me call them Bx, By because of the rod. Then TAB is being applied, which is equal to T0. Okay? And because of the contact, a force comes and we assume that there is no friction, so it is just in the tangential direction. So, so if a normal force comes, it will not matter. We put a force F. Now, if I take moments about B is equal to 0, what do I get? F times radius at B is equal to T0. Okay? Now what I'll do is, I draw, so this is FBD of gear at B. We draw the FBD of the gear at C. Now, the common thing between this and the old other free body diagram is that an opposite force F is going to act on the gear at C. Then we have Cx and Cy and let it cause a torque TCD. I have shown it in the right sense. I could have shown it in the opposite sense. I would have got the answer with the minus sign. So now what this tells me is F times the radius at C will be equal to TCD. Okay? So F times so what do I get from here? I get the torque which is transmitted in CD. How is that related to T0 using this relation? It is a ratio of the two radii. Okay? But when you do it through F, it becomes very clear why it is the ratio of the two radii. Okay? And then the other thing which I need here, so from here what I can do is, when I work it out, I will get TCD. So F into 22 mm is equal to T0 and F into 60 mm is equal to T times T of CD. And so this gives me, what is this happening? TCD is equal to 2.73 times T0. Now, let us look at the two radii, two gears. So now, If the angle of twist on the right side is phi c and the angle of twist on the left side is phi b, then what is the relation between phi b and phi c? So now here we get RC times phi c is equal to RB times phi b. So this will give us phi b is equal to phi c into RC upon RB. So this will be equal to phi c into 60 upon 22, and we'll get actually the same number, 2.73 phi c is equal to phi. Once we have got these two things, then I think solving this problem should be no big deal. And let me complete it for you. So then if we look at the shaft AB, then we have T0 here. So we will get an TAB. So we use a formula. The shear stress is equal to TABC upon J. And what we get from here is, for tau, we put in the maximum value to get the value of TAB. So 55 into 10 to the power of 6 is equal to T0 into 9.5 into 10 to the power of minus 3. Now the reason I am going through this example in full details is, please, for this course at least, we will be needing calculators. We will not be able to do anything without calculators, but be very careful about the units. The maximum value of tau was given as 55 megapascals. We are converting everything to SI units. So 55, so don't forget the 10 to the power of 6. Don't just put it as 55. And then is equal to T times C. Now T is T0, which we don't know in this problem. C was the radius. So another common mistake is using diameter, not radius. So it was 19, so that's why we get 9.5, but it was in millimeters. So convert it to meters. And then pi by 2 times C to the power of 4. So once again, you have to put 10 to the power of minus 3 there and to the power of 4. And obviously, you can't do this calculation by hand. Even the approximation will be difficult. So, and another thing with calculators is, please, phones will not be allowed. So if you are used to using your phone as a calculator, try to use some other calculator which you will bring for the exam and quizzes, and you have to sort of just use that calculator. Is that fine? And so you should know, because what happened was, I got a new calculator, somebody came and gave it to me, I tried to use it, I just could not use it, because the way my old calculator had an equal to sign, the new calculator did not have any equal to sign. It had an EXE instead of equal to. It took me some time to figure out. And then sometimes in the new calculators, you just have to put each thing in the same order. But in the old calculators, it was different. How do you do power 4 and things like that? How do you do sine, cosine, tangent and theta, or in radians or in degrees? All these, so you should have to be familiar with how to use the calculator. Otherwise, you may make some errors. So this way, okay, continuing back to this problem, when we do this, we get, using the shaft AB, what we get is T0 must be equal to 74.1 Newton meters. Now, if I look at shaft CD, in the shaft CD, what I have will be TCD, and opposite of this will come on the other end. And what we know is TCD is equal to 2.73 T0. So I assume T0 is an unknown here and I work out. So now tau max is equal to TCD C upon J for rod, what's it called, CD. Now work, find T0 based on this. So this will give me 55 into 10 to the power of 6 is equal to 2.73 T0 into 12.5 into 10 to the power of minus 3 divided by pi by 2 . And this implies T0 is equal to. So working out T0 based on this second estimate, I get T0 is equal to 61.8 Newton meters. So which one should I use? 71 or 61? 61, because this is the one at which it will fail. So that means the maximum T0 which the system can take will be 61.8 Newton meters. Okay. So this is what we'll have to do. So maximum torque will be smallest permissible T0. So this will be equal to 61.8 Newton. Now for the rotation, torque in AB is equal to T0 is equal to 61.8. So phi of A with respect to B is equal to TAB LAB upon J times G, and this again if I work out the answer 61.8, this is Newton meters. So it's just the same. LAB is 0.6 meters divided by pi by 2 into 0.0095 to the power of 4 and then multiplied by 77 into 10 to the power of 6. So if you put in all these, you get the answer as 0.0376 radians. So once you get the torque, you get A will rotate with respect to B by 0.0376 radians, and again one of the purpose of going till the end is to ensure that if you have to give the answer in degrees, what you will get from the formula will be in radians. So you have to then convert it into degrees. But then this is not the final answer, because this is only phi of A with respect to B. If I look at the shaft CD, then tension in CD is equal to 2.73 T0 So then what I do is I could have started with phi of CD first also. First I calculate how much C rotates. Now D is fixed. So C with respect to D is the absolute rotation of C. Given phi C, then I work out the value of how much B rotates, and then we have worked out how A rotates with respect to B, so add that and we get the answer. Another thing I want to sort of show to you is that everywhere where I have calculated, I am not carrying numbers to 10 decimal places, etc. I am following the rule which I told you. If an answer does not start with 1, then I carry 3 digits. And if starts with 1, then I carry 4 digits. And the final answer, this 10.2 probably is 10.20. So that's why I've just written it as 10.2. So, of course, I'll not be very particular even if you carry more, but there's no point in carrying your answers. At least the final answer you should give in terms of 3 or 4 significant digits, not 10 or 12. Okay. So that's it. Are there any questions on this? So this is how we can solve problems of torsion. Okay. So think of some mechanics will have to be used, some of these relations, and then compatibility. We'll have to think of this. So that is the basic sort of this which we'll be using. Okay. Any questions? Like, it seemed to be. Anyway. So now I'll do more problems from the earlier part, but not today. Let them be covered in the tutorial, and I will cover 1 or 2 more of those problems. But just as I have done today, it takes some time. Normally, we leave this for the tutorials, but I'm not sure. But I think, how are the tutorials going? It's just some feedback. Okay, 2-3 हुए होंगे. 3 I think you must have had. Let's say, I'll ask with each group. Thursday group, are you happy? Thursday वाले कितने लोग हैं? Is the teacher fine? You're solving okay. Friday, मतलब problems are being solved. ठीक है, नहीं स्लो तो देखो फिर it does happen in the tutorial. And also as you, अभी हमने होमवर्क कितना फर्स्ट होमवर्क लगा दिया है. अच्छा, अदर थिंग इज ये होमवर्क सबमिशन में जब आप लोग इतना डिले करते हो, people keep on coming 1 or 2 days later. Problem is then I can't put up the solutions till then. So now I think tutorial 2 के जो solutions है उसको लगा दीजिए. और इसीलिए I wanted tutorial 3 to be submitted today, but some of you have requested me, so now it will be on Monday. So Monday में let us fix up the time. In the lecture you have to submit. In case you are getting delayed, कुछ होता है तो give it to your friend. If you cannot come to the lecture, I am not saying that you have to submit it yourself. Some teachers insist on that. But still, if it is there, we will keep 12 o'clock as the deadline. And if after, or maybe 1 o'clock, and you can submit it in the, if you have missed it here, then the CFD lab, which is, at least some of you know, it's block 3. That is where all the teaching assistants are sitting. In block 3, first floor, there is the CFD lab. So there, but they have to be submitted here. That is only if you write to me, I cannot come, I will be late or something. And another thing which you can do is, if something has happened, just send a soft copy on that morning. Not everybody should do that, only 1 or 2. Otherwise, I can't keep on taking printouts of your soft copies. And other thing, of course, I have told you, grading of these will be given back to you late. So keep soft copies of your homework submissions with you, because TAs will grade them, but it will take time. So if you need them for preparation for exam or quizzes, keep your soft copies with you. So soft copy, अगर बहुत ही urgency और कुछ बहुत dire situation आ गई है, तो अपने assignment की soft copy भेज दो by the due date or by the due time. Due time is the lecture actually. So ट्यूटोरियल 2 आई विल बी, सबने सबमिट कर दिया होगा जिसको भी अभी तक करना था. 1-2 लोगों के लेट सबमिट, लेट्स नॉट हैव लेट सबमिशंस. जनरली आई डोंट एनकरेज देम, बट I don't want to be too inhuman. So, okay. Now we will move on. So again, what you will find is if you follow the textbook, I am covering only the first portion of the text, of each chapter. The second portion consists of when you go in the plastic limit. So that part I am not doing because we only have half the time for solids and half for fluids. So at least this is just to give you. So we are not going at all in the plastic zone. Because some of these problems, when you solve in the plastic zone, then what actually is given is instead of giving the value of G, they will give you the stress strain diagram. And it's not very difficult. So from that stress strain diagram, you don't use G. You calculate stress and you calculate strains. And then you solve in the same way. So if you have to use plastic deformation, there's no big deal, except the process may become iterative. Here, because there is a constant G or a constant E, then you have a value for it. There you have to calculate stress versus strain, not from the formula, but from the curve. So you read those values from the curve. That's all what one has to do. Next, we'll move on to chapter 4. We are going very fast, it seems like that, but that is because we are also not covering the full chapters. And also I think a bit has happened because of 3 lectures. So, अगले हफ्ते भी कर ले 3 lectures? नहीं, क्योंकि उसके बाद उसके नहीं, but I can make do with 2 also next week because I'm not going, I was planning to be away for 2 days in the week after that, but I'll be away only for 1 day. So, it's up to you. You find the Tuesday lecture more convenient than mornings or? है? Morning ठीक है, तो चलो जहाँ जरूरी होगा वहाँ. तो next week we'll have only 2 then. बट एक फिर क्विज जब लेंगे, क्विज की डेट भी फिक्स करनी है. क्विज कब करनी है? हाँ नहीं, that one can do. So I am okay. We can fix up a quiz that day. I will not be here on 10th of February. So 10th को 8:15 पे we can start the quiz. It will go till about 9:10 or so. 3 questions. And when I say quiz will have 3 questions, each question will be counted as a separate quiz. So think of it as 3 quizzes, because then I will take, the reason is, then I will count the best 4 or best 5 out of 6. So one of the question which is you have not attempted will be dropped. When I find, so we'll aim for a total of 9 questions or 12. So 3 or 4 quizzes. So in each, I will count a separate question as a separate quiz. And then I will count the best, whatever, n-2 or n-1 out of n. Okay. And please don't miss the quiz because, well, if you miss the minor or the quiz because of a medical reason, a very valid reason for which you give me a certificate, we will take a makeup. But let me make it very clear, even if you actually had a problem, my makeups will be more difficult than the regular ones. The regular questions, for whether it is a minor or for a quiz, the makeup question, makeup exam definitely will be a level higher. Because you are, when you take a normal exam, you have 6 exams, you are taking it. When you have a makeup, that's the only exam. So I can't, to be fair to all, the makeup has to be tougher. Okay. So best is not to go for the makeup. कई बार लोग प्लान करते नहीं मेकअप ले लेंगे तो वो मत करना. It is in your benefit. नहीं तो जिस दिन, अभी तो तुम्ही ने तो सजेस्ट किया था कि जब लेक्चर, नहीं वो मुश्किल होगा क्योंकि लेक्चर वाले दिन एम स्लॉट होता है. तो वी कुड हैव इट ऑन ट्यूसडे इवनिंग दैट डे, बट उसमें क्या होगा, मेरे को रूम और बुक करना पड़ेगा. Advantage of this is in this room we can easily have the quiz. Well, pardon, 8:15 is fine, I think. So our quiz date is now fixed. 10th of February. I will not be there. They will conduct the quiz, but it will be, we'll have 3 questions and level will be almost of assignment. So the quiz is, if you have done the assignment, so you don't have to prepare too much for the quiz. See, you should have this training कि quiz होगी तो होने दो, कोई फर्क नहीं पड़ता, दिखा देंगे टीचर को हम कि हमें आता है. Go with that attitude and I think, and at least I'll be very happy if people have that attitude कि दिखा देंगे हमें भी आता है, ठीक है. I have no egos and I'll be okay. So now I'll introduce this concept and the derivations of this we will do later, but अभी class खत्म नहीं हुई, अभी काफी time है. It's so let's see. We will look at normal stress I look at a prismatic rod or a prismatic bar. Now, what do we mean by a bar or a rod? The length is much bigger than a cross section. That is a rod. Now, what is a prismatic? Prismatic means the area of cross section stays the same. Okay, so we have the same area of cross section, and the area of cross section could have any shape. For example, here I have shown a trapezoidal shape. Okay, so this is a prismatic rod. Now, let us first define the directions. The location of the coordinate axis origin we will come to later. The rod direction is along x. Okay. The y direction is perpendicular here and z direction is the transverse direction. So, this face which we have in the cross section, this is in the yz plane. This one, so this cross section is in the yz plane. And the loading is moment m and m prime on opposite ends and the moment m is about the z axis. So, this is the z axis. So, the moment is about the z axis. Okay. So, what effect will such a moment do to this rod? Just think about that. What will this, because of this moment which is there, what will be the deformed shape of the rod? So, this is the rod, that is the z axis. So, moment is about the z axis. That means if I don't want to break my pen. एक ही पेन है लिखने वाला, महंगा भी बहुत आता है. This will tend to curve, create a curvature in this rod. So because of this moment, if this was the initial shape and we have moment like this, M will curve the rod. Okay, this M is about Z axis. So Z axis means you apply at the moment. So then that rod will tend to be curved. Okay. So in torsion, we had a twisting moment. Here we have a bending moment. Did you do shear force bending moment diagrams in APL 100? किया होगा नहीं. जब स्टैटिक्स किया था, ट्रसेस किया था, shear force bending moment किया था. किसने पढ़ाया था? कपूरिया प्रतीक गुप्ता ने? सुषमा प्रभा, उन्होंने तो कराया होगा. नहीं, नॉट श्योर. ओके, अभी करा. Can अभी we'll come to that, not now. But so anyway, so if I think of this, if I look at this rod, if I apply a transverse force, that is what is going to cause a moment like this. If I put on here, if this is fixed on the wall and I put a vertical force, that is what will tend to curve. I put a horizontal force, that will curve it in the other plane. Okay. So this is what we call as bending. Now I have used another word, pure bending. Okay. I am explaining all of these. I explained what is a rod. I explained prismatic. Then I explained bending. Now I am explaining pure bending. Pure bending means the section which we are looking, it only has two opposite moments acting. There are no other force which acts. So pure bending means only I have drawn them opposite. मतलब एक इस तरफ है, एक इस तरफ है, because that is only then it will be in equilibrium. ठीक है ना? So basically it is something like they are about the Z axis. So they could be about the Y axis, but then the bending would be in a different plane. We are looking at bending like this. The same equation will hold for the other bending also. In 3D case, so we have the axis of the rod. We could either bend it because of the moment about Z axis, or a moment about Y axis will also bend it. Okay. But this analysis which we are doing is for these members like this, which are, so pure bending means there is only bending moment acting on the rod. So M prime are on the same longitudinal plane. Now, where do we get such pure bending? ये किस चीज का कार्टून बनाया मैंने? वेरी बैड फिगर. This is one of the sports where we win sometimes medals in the Olympics. बाकी में तो नहीं मिलते हैं, कम में ही मिलते हैं. So when somebody is lifting a weight, okay. So now if we look at this rod, Now, if I draw free body diagram, so this is I was told this works. Weightlifting, and if I draw free body diagram, let's say these weights of in weightlifting the weights are symmetric. So the two weights, let's say whatever the weights are, this weight will come and we will have R1 and R2. This 400 newtons on the two end is given to you. Okay. So that means basically the person is lifting about an 80 kg weight, 40 kg on each side. Hai? So that makes it 80 kg. So is it Maleshwari or is it someone else who will lift this much? Pata nahi. Do you know the name Maleshwari or no? Weightlifter. What is so prominent about Maleshwari? दो सिल्वर. She was the first lady Olympian to win a medal for India. She won it long back, I think, in Australia when we had the last Olympics. Now there was this. Who was the other one? There was one who won in Japan also. Mirabai Chanu. Yeah. So she won the silver, I think, or was it bronze? I don't remember. Anyway, so now here, what will R1 and R2 be? Again 400 newtons. By symmetry you can make it obvious that they will be equal. So now what you find is, so this R1 is equal to 400 newtons and R2 is equal to 400 newtons. So this portion CD, if you look at R1 and the left 400, they make a couple, and R2 and the right 400, they make a couple. So the portion CD is in pure bending. Okay. So I'm giving you an example where things are in pure bending. So the portion CD of the rod will be in pure bending. Is that clear? Because now there are couples acting there. So CD is in pure bending. So this is the geometry. Now, the reason why we analyze pure bending is that pure bending, we are able to make a simple theory for pure bending, and we can relate these moments to the stresses. That is what, of course, all we are trying to do is relate forces to stresses or relate moments to stresses, because that is what eventually causes failure. Now, we can also use the results for two cases. Eccentric loading and transverse loading. Let me explain what we mean by suppose this shows a vise in which you are clamping this. So that means you can move the two ends of the device, then the AB cylinder is being clamped between the two horizontal rods. Okay. So we have cylinder AB is clamped by the vice. So if I draw the free body diagram of a cut section of the vice, then on this part, when AB is being compressed, it will exert a force P on the vice. So if I draw a free body diagram, I will get here P, and on this cut section, I will get P prime, and let us say there is a moment M. So P, let us assume, is known. On the cut section, the forces which will come will be P prime and moment M. Okay. Now, what is P prime equal to? If we do now equilibrium analysis, P prime will be equal to P. And what will be the moment M equal to? It will be P times this horizontal distance. So let's say if this distance is E. So what I will get is M plus P times E is equal to 0. This is moment balance. So M is equal to minus P. So that means M will be equal to PE in the opposite sense. So in this rod we will have, in the straight vertical part, there is a moment along with the axial force which is acting. If I cut any section, I get a moment which is again a bending moment. So the results which we will get, we can use for this. That means we will have to superpose the deformations due to P and the deformation due to M. We can always do that. So provided we are in the linear range and deformations are small. So this is one example where we can extend the pure bending. And the other thing which I said was transverse loading, which is suppose I have a rod clamped in the wall, and there's a transverse means not along the direction of the rod, but load acting like this. Now, if I cut this section at X, and once again if this is force P, so I will get on the cut section a moment M and a force P. So again, I get a bending moment, and the results which we get for pure bending, we will extend them and use them in these cases. So now, what we will do in the next class is, we will look at symmetric members in pure bending. So I'll also explain the term symmetric, but in the next class. In the next class, we will do this analysis of what are the stresses which come because of the bending moment. In general, if we have x, y, z, so there will be 6 stresses: sigma x, sigma y, sigma z, tau x, tau y, tau z, tau x, y, tau x, z, tau y, z. So which stresses come because of pure bending? And that is what, and how to find them, how to relate them to the property of the bars. So that is what we will do in class on Monday. Okay. So now we have decided quiz will be on 10th of February at 8:15 in the morning in this. It's a 45-minute quiz. So we end up at 9, 5 minutes extra de denge, but by 9:10 everything should be collected and over. सीटिंग प्लान क्विज का कुछ बना देंगे. सिलेबस अच्छा, अभी तो 10th फरवरी है, काफी टाइम है, बट लेट्स से फर्स्ट 4 असाइनमेंट्स कर दें तो अच्छा है, तुम्हारी माइनर की भी तैयारी हो जाएगी. भाई फर्स्ट असाइनमेंट वाज टेंसर्स, सेकंड वाज चैप्टर 1, third assignment is chapter 2, the linear PL delta is equal to PL upon any type of things, and fourth assignment is torsion. So up to torsion, bending नहीं पूछेंगे, बट पढ़ लेना क्योंकि माइनर में तो काम आएगा ही. ठीक है. अच्छा, हाउ मेनी ऑफ यू आर नॉन टेक्सटाइल, नॉन एनर्जी? कितने? काफी सारे लोग हैं. ठीक है, मतलब क्लास में आ रहे हैं ना वो लोग. That is what I wanted to see, that they should be at least for core people. बाकी सब core वाले हैं, बट कोर्स समझ में आ रहा है, कोई प्रॉब्लम तो नहीं हो रही. अगर कुछ इशू हो तो you are always free to write to me, to come and tell me anything you want. Anything is not clear, you don't understand, you can ask me after the class, or send a mail to me, fix up a time. I don't fix office hours because कोई आता नहीं है उनमें. But you can write to me and come to me, take a time now and after the class.